The Hyplex pump is a powerful, ultra-high pressure pump developed for use by Flow International Corporation, the world leader in UHP water jet technology. The Hyplex pump is designed for minimum maintenance and reliable performance at full-scale industrial use. In this video, we have positioned the Hyplex cutting machine and Hyplex pump skid for ease of access. In the next several minutes, you will become acquainted with periodic maintenance and troubleshooting procedures for the Hyplex pump. Use this video as a supplement to your operator and service manual and hands-on training from your supervisor in Flow International. Getting the maximum life, safety, and efficiency from your Hyplex pump will depend on daily inspections and periodic maintenance. Periodic maintenance can be regular scheduled preventive maintenance, and it also includes replacing worn parts that have reached the end of their life. By implementing regular, effective periodic maintenance, you will minimize unscheduled downtime, maximize equipment utilization, and eliminate unsafe operations. Here are some tips to get you started. Stock enough spare parts to eliminate downtime. Keep your work area clean. Keep a complete set of service tools with the Hyplex. Use only Flow replacement parts and follow Flow's recommended periodic maintenance schedule. Use only high-pressure fittings, valves, and tubing certified for 60,000 psi. Immediately repair any leaks in the fittings or connections. Do not over-torque fittings to stop leakage. Clear all personnel from the area when you pressurize any new, rebuilt, or serviced high-pressure component for the first 3 minutes of operation. Make sure high-pressure water is bled down before servicing any part of the system. Using the right tool makes any job easier and more effective. Here are some guidelines for using tools on your Hyplex pump. Use only approved test equipment and check it regularly for proper operation and calibration. Use the proper tools for the job, otherwise you may damage your equipment or injure yourself. Clear all tools and rags from around the machine after servicing and before starting the pump. Keep a supply of Flow special tools on hand in order to cover all maintenance requirements. Treat the Hyplex ultra-high pressure pump as you would any other high-speed cutting tool. Although the water jet may seem harmless, it is a high-energy tool. Careless operation can be extremely hazardous, but if you follow simple precautions, the Hyplex pump will perform both efficiently and safely. Never start the system unless you know how to stop it. Do not allow the water jet stream to touch any part of your body. It will cause serious injury. When servicing the equipment, shut it down and mark it with a warning sign. Wear appropriate clothing and safety gear. Always consult your operator's manual, complete safety guidelines and practices. Your operation and service manual contains step-by-step instructions and illustrations that explain how to service the Hyplex pump. Here are some general service tips. Inspect the system every day prior to operation. If you see any discrepancy, correct the problem. Read and thoroughly understand each service procedure before starting the work. If you have questions about any of the procedures, contact Flow's Technical Service Department. Ensure the power is turned off and pressure relieved before starting any service. Handle critical parts with care and avoid scratching or denting ultra-high pressure water system components. Make sure all operating parts of the machine are clean. Inspect the area around the equipment for unnecessary parts, tools, and rags. Remove them before operating the equipment. Maintain a service log. It will provide important information to help you stock spare parts and diagnose problems. The Hyplex pump requires several ultra-high pressure water components to maintain 55,000 psi. The water for this system starts with your facility's water source and is passed through two particle filters with 1.5 micron absolute ratings. This filtered water is then routed into the Hyplex pump and ported to the inlet side of the three check valve assemblies. When the 30, 50, or 75 horsepower motor is started, a crankshaft rotates, causing the three water plungers to stroke in and out. On the water inlet stroke, the plunger is retracting, creating low pressure in the high pressure cylinder. The inlet poppet on the check valve assembly opens, allowing filtered water to fill the cylinder. After the plunger is fully retracted, it begins to extend on the compression stroke. This increases the water pressure in the cylinder, which causes the inlet poppet to close. At the same time, the outlet poppet in the check valve opens and ports the ultra-high pressure water into the end cap, and then the high pressure port of the manifold. All three cylinder assemblies supply 55,000 psi water pressure to the same manifold at alternate times to maintain a constant output pressure. As the 55,000 pounds of water pressure exits the manifold, it is directed to two locations. The first is the pressure control valve, referred to as the PCV. On the 75 horsepower pump, this is referred to as an external compensation valve, or ECV. The electronic pressure regulator adjusts this valve to increase water pressure to 55,000 psi, or set at low pressure, decreases it to as low as 5,000 psi. This valve relieves the excess volume of high-pressure water to maintain a constant pressure when the cutting head is on or off. It also dumps all water out of the high-pressure lines when the Hyplex pump is turned off. The second direction the high-pressure water goes is to the cutting head. The on-off valve turns the flow of high-pressure water on and off by use of an air signal. The quarter-inch fitting on the front of the manifold goes to the pressure transducer. This sends a digital signal to either the flow cut screen or the LED display. Maintaining good water quality and maintenance practices will ensure optimum life of these components. This training will focus on the minor and major service procedures. The service intervals will be dependent upon what the horsepower rating of your pump is. For a 30 horsepower pump, the minor procedure is done every 700 hours, with a major service performed every 4 cycles, or 2,800 hours. Likewise, for the 50 horsepower pump, the minor procedure is done every 500 hours, with the major procedure done at 2,000, or every 4th interval. And for the 75 horsepower pump, it is every 300 hours for the minor and 1,200 hours for the major procedures. All scheduled service intervals should be performed as preventive maintenance. If trouble reveals poor pump performance, or if the pump fails in between any of the service intervals, you must judge whether to correct the individual problem or to perform the complete service procedure. Generally, if the trouble occurs within 50 hours of a scheduled service interval, a complete service procedure is performed. If the complete procedure is performed prior to the scheduled interval, ensure that the next interval is scheduled at the appropriate interval from the time of repair. Note, this video separates the service intervals into specific maintenance items. The service procedures in the Hyplex Maintenance Manual contain all the following procedures under one title. This procedure explains how to access and service the check valves. If check valve performance decreases or a check valve fails prior to a scheduled maintenance interval, then perform the maintenance required to fix the problem. Heat at the end cap can be an indication that a check valve is leaking past a poppet internally and check valve service is required. If a small scratch or excessive wear on the inlet or outlet poppet occurs, the Hyplex pump will not maintain maximum pressure. High pressure water leaking past a poppet creates heat that can be felt at the end cap or high pressure cylinder. To service the check valve, first shut down the system and place the main electrical disconnect in the off position and lock it out. Disconnect the low pressure water hose from the manifold. Remove the high pressure water connections from the manifold. Remove the 6 hex bolts from the top of the manifold and lift off the manifold. Remove the 4 hex nuts and washers from each end cap. If all cylinders do not require maintenance, the other end caps can remain torqued in place. Remove the end cap from the high pressure cylinder by prying with a small screwdriver in the slot between the end cap and high pressure cylinder. Take care not to damage the guide sleeve on the cylinder during this procedure. On a workbench, remove the check valve from the end cap by placing the tips of 2 small screwdrivers in the grooves provided on the check valve. Remove the O-ring from the outside of the check valve and place the check valve assembly in the flow check valve fixture with the outlet cage exposed. Remove the cage. Remove the compression spring, outlet poppet assembly, and outlet seat. Remove the inlet poppet from the high pressure cylinder and then remove the inlet poppet retaining spring. Discard the inlet poppet poppet guide and seat. The end cap static seal may be compressed onto the check valve body. Do not attempt to remove it unless it shows signs of damage or leaking. Clean all the check valve parts with solvent and compressed air. Inspect the check valve body for signs of wear, erosion, or pitting. Replace as needed. If this is a scheduled minor maintenance interval, replace the inlet poppet poppet guide and seat. The major repair service replaces the entire check valve assembly. If deep scratches, erosion tracks, or cracks are found on the inlet face of the check valve body, it should be replaced. If normal wear or minor damage is found on the inlet face of the check valve body, it should be lapped. To lap the inlet face of the check valve body, attach a piece of 320 grit adhesive-backed abrasive paper to the glass lapping plate and place a few drops of water onto the paper. Using a figure-8 pattern, lap the check valve face until all wear or damage is removed and the entire check valve surface has been lapped. After 10 to 12 lapping motions, rotate valve body 45 degrees. Remember, flatness is critical. If the face is not flat, the inlet poppet will leak. Clean the part thoroughly to remove any abrasive particles from the face and bores. Reassemble the check valve. Place the spring onto the outlet poppet assembly and insert them into the cage spring first. Install the outlet seat over the outlet poppet so that it fits into the cage. Compress the outlet seat onto the outlet poppet and ensure that the spring force alone will push the outlet seat away from the outlet cage. Replace if the spring is not able to unseat the poppet. Apply blue lubricant to the cage threads and install the cage into the check valve with the check valve being held vertically to ensure the outlet seat remains in the cage. Place the check valve assembly into the flow check valve fixture and torque to 20 foot-pounds. Lubricate the O-ring with white food-grade O-ring lubricant and install it on the outside of the body. Remove the two O-rings and high-pressure seal from the end cap and clean the end cap using solvent and compressed air. Inspect the end cap for cracks, erosion, and pitting. Replace if needed. Inspect the O-rings and high-pressure seal for damage. Replace them if needed. Lubricate the O-rings and high-pressure seal with a small amount of white food-grade O-ring lubricant and install them into the grooves in the end cap. If the static seal was removed, install the seal onto the outlet side of the check valve body and insert the check valve into the end cap. Install the inlet poppet and the check valve back into the pump using the minor repair service procedure. Return the pump to service following the startup instructions in the manual. An external leak or heat in the area of the seal carrier and dynamic seal may be indicators that the high-pressure pump requires maintenance. If a dynamic seal fails, it generally is an internal leak. The high-pressure water leaks past the dynamic seal and into the cooling water system. This can be detected by heat at the high-pressure cylinder or a warning in flow cut from the thermistor sensors. This procedure explains how to inspect and replace the high-pressure pump components. Remove the check valves following the check valve portion of the service procedure. The end cap and high-pressure cylinder static seals usually come out with the check valve. Leave them on the check valve and inspect the seals. Replace if needed. Service the check valve as needed per